It's section 5.2 on probability distributions. Now wait a minute. Isn't this like just a compound word that's made up of stuff we already learned about, right? I mean, look at the course calendar for a second. Let me punch that up. Where'd I put it? Oh yeah, there's your formula page. Course information. Course schedule, right? And by the way, if you're looking at the course schedule, zoom out a little bit, right? There's our first 2 weeks. You will notice that week 3 has no homework listed yet, right? That will change shortly. Okay, that will change shortly. But at least I was happy I planned out the first 2 weeks of this course, okay? You know what my homework is for today. Anyways, looking at these things, of course, chapter 4 was all about probability, right? So we spent a long time working on that. And then where did we cover distributions? Yeah. That first thing we did, chapter 2, we covered frequency distributions, right? This is a little different. This is a probability distribution. And by the way, when you guys did frequency distributions, there was a type of graph that went with it, which was called a histogram. Well, in this chapter, we're going to draw a couple of probability histograms as well. Okay? So what you did before really ties in nicely with what we're going to do now in this chapter. And that's kind of good. Now, one idea, I guess the difference between this and the old distributions is that instead of frequencies, we're going to have probabilities. That's what I would say. But one idea that I think is important is the following. And it's not particularly emphasized in our book, but I think it's very useful. And it's this: associated with a probability distribution is what we call a random variable. I want to underline that because that's a new word for us. Random variable. I think I may have used it once in the course already, okay? But I want to say exactly what I mean by it. A random variable is a variable that takes on different values with different probabilities.
It's such a better description than the book said.
I told you I don't think the book says very much what a random variable is. Yeah.
A variable that has a single numerical value determined by chance.
By chance. Right. Okay. So let's do a couple of examples here. And I want to do examples that we've already seen because I think that actually will help the most. I'm going to start off, and we'll usually use capital letters for random variables. Lowercase letters are what you guys used in your algebra class usually, right? So I'm going to use a capital letter, and I'm going to talk about x. I'm going to say x is the value I roll on a standard die. Okay? And if I say that that's x, capital X, then what I can do with that is I can show you what the probability distribution would look like. It would look like this. Probability distribution of x, okay? Well, we can make a little, remember how the very first thing we did in this class was we made what are called frequency tables? Okay? So what I'm going to do is I'm going to give you some various values little x, and then over here I'm going to have a column that says the probability that big X equals little x. Although, actually, this is kind of a boring example because, well, you'll see momentarily, right? What are the different values you could get when you roll one die? We know that. 1, 2, 3, 4, 5, and 6, right? And what's the probability of X equaling any one of those particular? Yeah, so that's kind of boring. Okay, so that's an example, but it's a boring example. What a better example, I guess, would be the following. Let's do this. Let's let y be the sum that appears on 2 dice. We did this example already also, but we didn't formally call it a probability distribution. Okay? But I think it's worth our time. So I'm going to do the same thing. I'm going to have some values, I'll call it lowercase y, and I'll make a chart, and I'll have the probability that capital Y equals lowercase y. And what are the possible values of y? Almost. How do you roll a 1? Okay, 2 through 12, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so the probabilities of each of those, do you remember how we did this? I have it in my notes somewhere. I could flip back. Here, let me just remind you guys. We made that big chart. And so, do you remember what the denominator was of the fraction? In other words, what the size of the sample space was when you rolled 2 dice? There it is. Here, we did a couple of these. Oh, yeah. I guess I just started this problem, right? When we were talking about probability. I actually did use the word random variable here. But now it's really talked about in Chapter 5, right? So here's the sums. We computed a few of them. Why was this 1 out of 36? Well, because, right, you could see the ordered pairs. There's only one way to get it, right? What's the probability of rolling a 12? Same, because the only way to get that is 6 and 6, right? So that's also 1 out of 36. But what's the probability of rolling an 11?
Where's the 36 come from?
The reason we have 36 is because when you look at this grid represents all the possible die rolls, right?
Okay.
There are 6 rows and there are 6 columns.
Oh, okay.
So 36 possibilities. You with me? Now, if I ask you guys again, what's the probability of rolling an 11? We know it's going to be something out of 36. What would it be? How come? You can only roll 5 and 6? But wait a minute. What if you roll 6 and 5? So this is interesting. This is interesting. And you might remember we did this in class graphically on the computer. I had the computer run a simulation where it rolled the dice. And I will tell you that if you do it thousands of times, which is what we simulated, you will get twice as many 11s as you do 12s. Because even though, Brian, you roll the dice together, you have to treat them as being separate dice. And if I do that, there's only one way to get a 12, but there are two ways to get an 11. Do you guys follow that? So what's the most likely number to occur? We said 7, right? That was 6 out of 36. Right? So yeah, this is really what I wanted to do, was I wanted to complete this chart. All right? So let me complete it, I guess. Here we go. We have 1 out of 36 here. We have 2 out of 36 for 11. 6 out of 36. 3 out of 36. I did 1 out of 36 for 2. What about the probability of rolling a 3? Probability of rolling a 3. Absolutely. 2 out of 36. What's the probability of rolling a 5? I agree, because you could do 4, 1, 3, 2, 2, 3, or 1, 4. So that's 4 out of 36. And by now you see the pattern, right? What's the next probability going to be? 5 out of 36. Then 6 out of 36. And then what about 8? Well, I guess we should check. How can you roll an 8, guys? 2 and a 6, 6 and a 2. So here's 2 and a 6. Here's 6 and a 2. 5 and a 3, or 3 and a 5. And 4 and a 4. So how many are there? 1, 2, 3, 4, 5 out of 36, right? So this is where it starts going back down. Okay? And so if we wanted to, we could graph the probability distribution, right? You might call this a probability histogram, where what you do is you list the possibilities down here. So my classes are just the different values the random variable could take on. And instead of having frequencies on the side, you're going to have probabilities, right? So I guess the most common thing, the most likely thing to happen is you roll a 7. That would be 6 out of 36. This is 4 out of 36. This is 2 out of 36. Well, then what I can do is I can, make a little graph of what this looks like. It's a histogram, but this time the bars are probabilities. And this is useful, to people that are going to play games, for instance. I asked you guys if you had heard of that game, Settlers of Catan, and you guys said no. My other class did. By the way, I don't know who's interested in games. I just found out about this. Lakeland is having like a game fest. Are you with this, Calvin? No, it's like a game thing tomorrow.
That's the Connect, isn't it?
The Connect Fest is on a Wednesday coming up.
It was this Wednesday.
We just had it this Wednesday.
Oh, okay.
That was in the library.
Yeah, that was in the library.
This is a game competition which is from noon until 10 p.m. tomorrow. Not just competition, you just come for fun and play, what do they have? Board games, card games, and video games, I guess. But then they also have some competitions for some of this stuff. So anyways, just throw it out there if you're interested. What's that? Play what? Counter-Strike, yeah. I haven't played this game. So anyways, but this is a probability distribution, or a probability histogram, a visual representation of these things. Now, I want to do something here, which is I'd like to talk about how you compute the average die roll. This is kind of interesting, I think. Okay? So actually what I should do is I should show you the formula. Do I still have it up? Maybe I do. Let's see. Because I had that formula page for chapter 4. Do I still have the formula pages here? No. I could punch it up, though. It'll just take me a second. Well, probably quicker to just use the book. So in your book under that chapter 4 box, there's a chapter 5 box that we're going to use for next week's quiz, right? And so if I kind of take a look at that right now, I'll need the zoom button here for a second so you can see. This is the information for chapter 5. But I want to look at that very first letter. You guys know what that stands for? Mu. Remember that Greek letter mu? Do you remember what it means? So, it's the Greek letter M, but why do they use the Greek letter M? Because they're talking about a mean. Okay? So mu, it says, is sum of the x's times the probabilities. Well, okay, let me write that down. The formula, too big on my paper. The formula that I want to use, okay, it's going to be this one. Mu equals, we have to add up the x's times the probability that x equals x. That's the formula. It's on the card. I guess when your book writes it, they don't write the equation here, big X equals little x. I like to write that. I think it's more understandable. It's the probability that my random variable equals a certain value. Okay? So basically what that formula tells me I have to do,
So the random value is the big X?
the big X is the random variable. Yeah, it takes on any of these values, 1 through 6, right? When you roll a die, you're going to get one of those values. Okay, so when we say we're going to compute the average, what we're going to do is we're going to multiply and we're going to add, which is interesting. That's a little different than what you normally do, I think. But what is it we want to multiply? Well, the x's times the probabilities. Now, guys, of course, on the calculator, I've shown you how to multiply columns together, but this is so small, we can just do it by hand right now. Ready? So what do we get? We get 1/6, 2/6, because we have to do 2 times 1/6, right? 3/6, 4/6, 5/6, and 6/6, right? So can you add those fractions? Sure, because they all have common denominator. So I know when I add them up, I can say that the mean is something over 6. What is it over 6? Well, 1 plus 2 plus 3. It's kind of like factorial, but it's adding, right? 21, I agree. 21 out of 6, which can be simplified, right? You can take a 3 out of top and bottom. You get 7 over 2. What's that as a decimal? 3.5. Please understand what that means. What the mean means? Yeah. And by the way, there's another name for mean. I'm going to give it to you now. Sometimes you will see this equation written this way. They'll write E of x is 3.5. And if you see it written that way, what we're saying, the way you read that is the expected value of the random variable, capital X. This is a capital X. Maybe I should put, somehow make sure you don't get them confused, okay? When you have a random variable, you could sometimes people will talk about what's the expected value. What they really mean is the average. I mean, when you roll a die, does anyone expect you're going to roll a 3.5? No. But what does it mean? You guys, this, I did a graph for the other probability distribution for Y. If I were to do a probability histogram here, what would it look like? Well, all the probabilities are 1/6, right? So it would look like this. Right? I mean, they're all equally likely. Where's the center of that distribution? Well, it's not really at 3 and it's not really at 4. It's really at 3.5. And that is what we just computed. Are you with me? Okay. Now, I am out of time, but I will tell you that a great exercise is to compute the mean of this probability distribution, and I think I'm going to start Monday's class with that. That's got to be done. All right? But you do have enough information to get started on the homework, I think, and that would be great. All right? Nice work this week, guys. 2 down, 6 to go. Been fun. I'll see you guys.